going on 33. Oh my God, that's right. It's 33 years already this year. Going on 33 years of senioritis. Okay. So I have no idea what day it is today. I know that it's 27. But you know how I always do this, like national unicorn national flip flop day. Is it? Is it for sure? There you go. National flip flop day. Happy National Flip Flop Day. Okay. All right. Well, and that's the kicker. Like because I've got senioritis now too. Like I get up like 5 minutes later than what I normally do, so I miss the big cheese going through the days of what the national days or what's celebrating today. So I missed that now because now I'm in the shower during that. I've already switched over to summer mode. Okay. Right. So which is fine. Okay. So this is the next one. If you had me yesterday, this is the next one to do. If you had Schmeling, you didn't quite get this far yesterday, which is fine. That's just fine. This is where we're going to start. Okay? So what I want to do here, just as a quick warm-up, is I want to add in a separate problem. So we're going to go 3A is find the AROC of this function from, give me an interval. I don't care what the two numbers are on the interval. 3 to 5? Okay, right? So from 3 to 5. So find me the AROC of this function from 3 seconds to 5 seconds. Okay? Go. It's not F, it's D. So if I plug 5 in there, that's going to be 47. If I plug 3 in there, that's going to be 15. 47 minus 15 is 32. So I get an AROC of 16. Yes? Huh? Okay. All right. Now, let's find the IROC at t equals 5. Okay. All right. So here we go. So my IROC is going to be the limit as h approaches 0 of d of 5 plus h minus d of 5 all over h. Well, d of 5 plus h. Let's go a little side action here. That's going to be 2 times 5 plus h quantity squared, then minus 3. So that's going to be 2 times 25 plus 10h plus h squared, still minus 3. So then that's going to be 50 plus 10h plus h squared minus 3, h squared plus 10h plus 47. Agree with that? Oh, yep. Good eyes. Is that better? 2h squared plus 20h plus 47? Okay. Yes, to answer the question, you still have to write the limit, okay, of h going to 0 until you send h to 0. It's got to be written down. Okay? So then this would be 2h squared plus 20h plus 47 minus, we had d of 5 over here, that was 47. All over h. So then this is the limit as h approaches 0 of 2h squared plus 20h over h. Limit as h approaches 0 of 2h plus 20. Now what can we do? Now we can send h to 0. Okay? So if h is 0, then this would become 2 times 0 plus 20. 2 times 0 is 0, plus 20 is 20, whatever units we would have. Okay? Ready to try one on your own? Again? All right, let's try this one. Find an IROC at t equals 3 with this new function. New function. Agree with me so far? Yeah? Okay. If I want to simplify the top, what do I have to have? Common denominator, right? Okay. So this is going to be my common denominator is going to be 2 times 4 plus h, right? Okay. So this first one is missing a 2. The second one is missing a 4 plus h. With me? Okay. So then this would become 4 minus h all over 2 times 4 plus h, still all over h. With fractions, got a fraction and a fraction. Do I like a fraction and a fraction? Okay, so what's my 3 words for dividing out fractions? Keep, change, flip. So this is going to be like negative h over 2 times quantity 4 plus h. That's my keep. I change my divide to a multiply. I change h over 1 to 1 over h. Now what can happen? Does h cancel out that h? So that leaves me the limit as h approaches 0 of negative 1 over 2 times 4 plus h. Correct? Can I send h to 0? Why not? Okay. All right. Send h to 0. Or I can't. Sorry. I can't send h to 0 because h is on the bottom. You look quizzical about your own answer. What would happen if I would send h? Would I get 0 down through? No, right? So can I send h to 0? Yes, I can. Because it's not just h or not being multiplied by h on the bottom. I can send h to 0. So then this would become negative 1 over 2 times 4 plus 0 there. 4 plus 0 is 4 times 2 is 8. So my IROC at t equals 3, right? T equals 3. Well, it worked out that t equals 3 is negative 1. Now, mathematically, it doesn't make sense to have to do all of this work for every single time we want to find the instantaneous rate of change. Because I'm not going to deny it. There was just a lot of work here going on. And if I gave you the next problem, if I told you the next problem is find the IROC of the same function at a different t value, you got to do all of that work over again. And then if I gave you in the next question said find it now at a different time value, you got to do all of that work over again and over again and over again, every different t value. Okay? So what we can do in place of that is we can find the IROC at any given time by making it a function. Okay? And then that way, one more, pass the graph. I'm skipping the graphs. Okay? We'll go right to it. So is it on there or not? No? Okay, so go back to the graphs then. Sorry. So go on that page. That's fine. Sorry, my fault. Okay? So we can make it a function. So our instantaneous rate of change, okay, at any time t, so now instead of t being an actual number, now we're going to leave t be t. And then once we find that instantaneous function, we can plug 78 t's in like that. And we can come up with all of these instantaneous rates of change. Okay? So my function here is going to be f of t plus h minus f of t all over h. Same function, okay? But now instead of it having a number for t, now you're going to have t for t. Okay? So if I want to find here my IROC at any given point in time t of this new function, that's going to be the limit as h approaches 0 of f of t plus h. Hold on. I just met spatially figuring out what I want to do here. Because I would be rewriting that exact same thing. Okay? So let's go over here. Let's do it this way. So I want to go f of t plus h. So that's going to be negative 3 times t plus h quantity squared plus 5 times t plus h. Okay. T plus h quantity squared not plus. I don't think anything combines in that statement. That just didn't good from the start. It's not over 5. Or so if I simplify that now, negative 3t squared minus negative 3t squared is going to be these two. They cancel each other out. Yes, they do. Okay? So then that leaves me with negative 6th minus 3h squared. 5t minus 5t cancels out. Right? Factor out an h, or divide every term by h. And now we can send h to 0. No? So my IROC at t is just negative 6t plus 5. With me? Okay. So now that I've done that work, now I can say to myself, self, what's the IROC at t equals 1? Negative 1. At t equals 2. Negative 7. At t equals 3. Negative 13. See how we're getting those? Everybody see how we're getting those? We're just plugging in those numbers now into my IROC function to get what the IROC is doing. Okay? What is this object doing? It is speeding up. So what does that mean? We're going to say we're on a two-dimensional plane. It's moving fast backwards. So instead of accelerating to Mr. Foster out there in the hallway, okay, I'm accelerating out the door. Okay? With me? Okay? So instead of it accelerating in a forward, because that would be a positive acceleration, right? It's accelerating. It's getting farther and farther away quicker from the starting. The numbers would be getting closer and closer to 0. Okay? So 0 would be stop. Okay? Does this function ever stop? Okay? When would this function have stopped? How do I know that? Set what? Set it equal to 0. So negative 6t plus 5 equals 0. Negative 6t equals negative 5. So t then would have to equal 5/6. So at 5/6 of a second, it stopped. Okay, we can use that now, okay? So let's go at a t value of 1/2. What's my instantaneous rate of change for a t value of 1/2? Positive 2. So can we describe a little bit more of what this object did? I'll be at the starting point. That way, so I'm pointed that way. Okay? What happened? What did I do based off of what we just mathematically showed? From the start? So I start by going forward, right? Because at t equals 1/2, I've got a positive IROC. So I start going forward. How long am I going forward? So 5/6 of a second, right? Then what happens? At 5/6 of a second, what happens? At 5/6 of a second, what happens? I'm stopped. Okay? Then what? Now I go back. Okay? So it's that little jump forward first, and then I go backwards. Okay? And we can get all of that from this. Okay? We know when that object stopped. Okay? We know that it was accelerating negatively, so going faster and faster and faster backwards. Okay? And we know that it had a positive less than 5/6. Okay? All right? Love it. All right. So this is now example number 6. Let's do How about we do this? How about we do example 6? Is there C? There's 3, so 3 more questions. Okay? And they're all good questions because now we've got all 3 different things that we can find on. Okay? So given that f of t is 30t minus 5t squared, represent the distance in meters an object is from its starting point after t seconds. Okay? Question A. How far is the object from its starting point after 2 seconds? What do we do? Plug 2 in for t where? In f of t, in our original function, nothing other than just plugging in 2, right? Don't have to do f of 2 plus h minus f of 2, all that fun stuff, right? Okay, so doing nothing but finding f of 2. $30 times 2 is 60. 2 squared is 4 times 5 is 20. So I get that the object is 40 meters away. Do we concur? Okay. What is the average rate of change over the interval 1 to 4? Okay, well, that's AROC. How am I going to find the AROC over the interval 1 to 4? Give me actual numbers. F of So I'm going to have to go over here on the side. F of 4 is going to be 30 times 4 minus 5 times 4 squared. 30 times 4 is 120. 16 times 5 is 80. So that's also 40. Do we agree with 40 for F of 4? Yeah. Then I got to do F of 1. And 25. 40 minus 25 is 15. 15 divided by 3 is 5 meters per second. Do we agree with that? Yeah. Now we have to find the instantaneous rate of change at any given time t. Okay. So that is going to be the IROC limit as h approaches 0 of f of t plus h minus f of t all over h. It's going to be 30 times t plus h minus that.
30t plus 30h minus 5t squared minus 10th minus 5h squared, and minus
So it was 30t. So I'm going to say minus here 30t plus 5t squared. I'm going to multiply that, distribute that negative sign into h, or into f, right from the jump. $30t minus 5t squared minus 5t squared.
So that's going to be 30 minus 10t minus 5h.
Can we send h to 0 now? Yeah? So my IROC function at any time t is 30 minus 10t. Does my function ever stop? Yeah? When? No? So it's moving away from us, right? At the start, because at 2 seconds it was 40 meters away. Okay? So it's moving away from us. It stops. Then what happens? Does it keep going? What happens? How can we tell? Plug in point. We already did those, didn't we? Right? Because we plugged in. So at 2 seconds, it was 40 meters away, right? Okay, that's before it stops, right? And then at 4 seconds, it's 40 meters away again. That's after it stopped, right? So it went out, stopped, and now it's coming back. Okay? Okay? Love it. Okay? So, giving you a second worksheet for today. Okay? So you've got the worksheet from yesterday. You've got this worksheet today. There's a lot of space for work. You're not. That's why there's a space. Don't be mad. Don't be mad at me for giving you work. Oh my God, you're so demanding. Anybody else need it? Yeah? Schmelling. So schmelling did is what you're saying? Need it?
I got it.
Need it? Need it? Need it? Need it?